Welcome back once again. So another video on digital basics, that is logic gates made simple with practical experiment. So in today's video, we will discuss about exclusive gates, that is XOR and XNOR. These two gates we call it as a specialty gates, or we call it as a exclusive gates. So we'll discuss about these two gates. So first of all, XOR gate. XOR stands for exclusive OR, logical operator that output true 1 if and only if its input are different. So according to the two triple, you will understand what if and only if when the inputs are different. Okay. So when the inputs are too different, then only you will get a logical high. Like inputs are here, like 0, 1 and 1, 0. You can see it here. So these are but not both are true. Okay, not both are true means both of them will not be true. So either it will be 0 or it will be 1. So XOR function is frequently used in digital circuits to manipulate signal that represent binary numbers. So that's why we call it as exclusive gate, that is XOR gate. So here actually you can see the typical diagram here over here, that is the gate diagram. And IC what we use is 74 series 7266, that is 266. This is the IC, but sometimes this IC is not available. So what I have done is, in the practical, I have used NAND gate. Okay, those gate I have used. In that using NAND gate, you can see here how the arrangement has been done so that I get the same output which I get from XOR gate. Okay, so this is the circuit for that. Okay. Now, second circuit will be about XNOR gate. Okay. So what is XNOR gate actually? XNOR or EXNOR, both we can call it as XNOR or EXNOR, is a digital logic gate designed for arithmetic and logical operation. Arithmetic and logical operation it is. But please remember, XOR or XNOR gate, both are specialized gate. Before that, the gates, what we have learned, these are the normal gates, the basic gates, we can say. So here, this is the figure, and 0, 1, 0, 0, we will just go for the two treble, and the IC used is 4077, 7-pin IC. And again, it is not available. So what I have done is, I have used 4 NOR gate, that is 7402 series, that IC have used and are given connection according to this diagram, so that I get output exactly as XNOR gate. So we will go to the lab and we will check the things over there. All right, friends. So we are in our lab now. So I'll just give you the idea first. What are the components and how it is interconnected? So again, the IC, the main IC, that is gate IC. So here we have used a gate IC that is 7400 series. So using this NAND gate IC, we are making a circuit for XOR or EXOR circuit by using 7400. So how's the arrangement that already I have given you? How the connection will be there. That is the input connection and output connection. Because here we are using all the 4 gates. So that's why this jumble is there. So in the IC, we already have 4 gates. So we are using all the 4 gates. We are interconnected the 4 gate. How it has been interconnected, you can see it in the schematic diagram. Okay. So the output, the logic output is the main part. Okay. So again, the supply voltage from battery. This is a low voltage. If this IC works on low voltage. 2 for the input A and B, I have connected to 10 kilo ohm resistor, and output, please remember, I have taken it from pin number 11. Output according to the circuit is taken through pin number 11 of the IC, which is given to the LED and another is given to the ground. Now let's see the position. Now what is the supply voltage we are going to count? Okay, so I will put this thing on the ground side, and let's see what is the condition on this side. So it is 0 here, this side also 0. So when it is 0, 0, it should be 0 according to the truth table. Right. So I will switch on this first. As you can see, the light has come. That means it is high. That is 1. We call it as. So 1 here, 0 here. So 0, 1. It is output is 1. Okay. 0, 1. The output is 1. Let's try this one. We'll on this one also. Let's see what happens here. It has come high. Here also it is high. Okay, so both these places 1 1, that means it will be 0, right? It will be 0. Okay, so one of the switch, if I close it, then again it will be this thing. So please remember XNOR gate, one of it, that is 0 1 or 1 0, the light will be high, that is 1. Okay, so this is the same circuit. I'm just explaining you. This is the working where we use it, that already have discussed. But how the XNOR circuit diagram is made on the breadboard. We are using now XNOR gate. The IC which we have used here is 7402. That is NOR gate IC. So you have 4 gates in this. So I've connected according to the circuit which I already have told you. I already told you, or I have already given you. Now we will check how it works. Like, we need to know the logic truth table. Okay, so we'll go for it. So I'm just this is ground point. Let's see what is the condition now. So one switch A, that is, it is high. Second switch is also high. That is 1 1 and 1. That is, the light is coming now. So 1 1 1, that is high high, then it is high. Now both the switches will close it. Even then it is high. 0 0 high. So this is XNOR gate. If suppose one of them is high or low, suppose this is high now, this is low, it will be closed. The same thing will happen with the other also. So I have used another IC for, because I was not having XNOR gate IC. So I have interconnected the 4 gates which are there. That is a 4 NOR gate. The IC number is 7402. And I have made an XNOR gate. So just now I've shown you the truth table. So where it is used, that already we have discussed. I hope you will like this thing. If you like, if you have any comments to make, or you have any questions about this, please do write to me. Right? Thanks for watching. See you next time.